Hello. For those of you in Miss Parker's class who don't know me, I am Mr. Boothman. I'm the other pre-calc teacher. For those of you in my classes, this is the first time you're hearing my voice do one of these videos. I'm super excited. Let's jump right into it. So today we'll be talking about our next section, 1.6, and combining functions. So we're going to learn how to add, subtract, multiply, and divide functions, and then we're also going to learn about something called composing functions. It sounds a little more difficult than it is. Don't worry, trust me, it's pretty easy. So let's start with our basic definition. Let f and g be two functions with domains a and b. So for f plus g of x, we define this as just f of x plus g of x. So why might we want to add two functions like this, or subtract, or divide, or what have you? There's a lot of different situations. The most practical that I can think of is perhaps you have two different jobs. Each job pays a different rate, so that's your two different functions, and then you want to add them and find out what your total pay will be. So, super easy, just add the two functions together. F minus g of x is f of x minus g of x. Again, pretty straightforward. If you're following the pattern, then f times g of x is f of x times g of x. And then f over g of x is f of x over g of x. So let's run through a couple of pretty simple examples. Let f of x equal x cubed and g of x equal the square root of x. So combine the functions and determine their domain. So let's start with f plus g. We said this is the same, according to our definition up here, as f of x plus g of x. So that's just going to be, we have our f of x here and our g of x here. So x cubed plus the square root of x. That's it. Pretty straightforward. F minus g is f of x minus g of x, again, based on our definition. So we have x cubed minus the square root of x. So hopefully I haven't confused you yet. Fg is f of x times g of x, which is x cubed times the square root of x. Now we can simplify this a little. If you remember the exponential notation for square root of x, then you know that this is really x cubed times x to the 1/2. X to the 1/2 power is the same as the square root of x. But this lets us combine our answers. We're multiplying, so we're adding the exponents. 3 plus 1/2 is 7/2. So this is really x to the 7/2 power. Finally, we have f over g, which is f of x over g of x, or x cubed over the square root of x. Now, we should probably rationalize this denominator. If we remember, that's just us getting rid of a radical in the denominator. It makes our function a whole lot nicer. So we multiply by 1. This is really 1 square root of x over the square root of x, but it gets rid of that radical. Square root of x times the square root of x is x. And now we can cancel an x in the numerator and the denominator, and we're left with x squared times the square root of x, or x squared times x to the 1/2, or x to the 5 over 2. So, if you need to, pause this right now. Make sure you understood exactly what I did. If you have questions, be sure to write them down. You can ask me or Miss Parker at the beginning of class when we start 1.6. Hopefully you're still with me. Let's move on to example B. We have actual numbers we're being asked to plug in. So we have f plus g of 4. What does that mean? Well, not sure why that's disappearing on me there. Well, we found f plus g. That was f of x plus g of x, or x cubed plus the square root of x. And we want to evaluate that combined function for 4. So, f of 4 plus g of 4. I'm just still using our definition here. F of x plus g of x. F of 4 plus g of 4, that is simply 4. Everywhere I see an x, I'm plugging in a 4, plus the square root of 4. 4 cubed, you can plug that into a calculator, or if you're like me, you've seen it enough times before, you know that that is 64, plus the square root of 4, which is 2. So our answer is 66. And I just realized I forgot in our part A of the example to determine the domain. So for any of these functions, remember we need to ask ourselves, we are looking for two things. Do I see a fraction? And do I see a radical? I don't see a fraction in any of these final answers, any of these combined functions. I do see some radicals. Remember that whatever inside the radical needs to be greater than or equal to 0. So I see an x. X has to be greater than or equal to 0 in each of these examples. So my domain for all 4 is just x must be greater than or equal to 0. Moving on, back down in part B, we have f minus g of 4. According to our definition, that's f of 4 minus g of 4. I sure wish this would stop disappearing on me. Is 4 cubed minus the square root of 4, or 64 minus 2, which is 62. Again, I really hope that I haven't lost you yet. This is mostly straightforward. If it's not, and you do have some problems with this, that's okay. Ask your questions, write them down so you remember them. Let's go ahead. I need a little more room, so I'm going to erase what we've done so far. So if you need to see f of g of 4 and f plus g of 4 and f minus g of 4, then pause the video now. Make sure you understand that. I'm erasing it so that I have room to do the other two parts of this. F times g of 3 is f of 3 times g of 3, which is f of 3. F is x cubed, so 3 cubed, times the square root of 3, which is 27 times the square root of 3. F over g of 3 is f of 3 over g of 3, which is 27 over... it's a good thing I looked. Always read the problem. Excellent example here. This is f over g of 1, not 3. Would have ended up with very different answers. So I have f of 1 over g of 1, which is 1 cubed over the square root of 1, which is 1 over 1, which is 1. Moving on. Let's go on to example 2. We have two new functions this time. Read the problem. F plus g of x is the same as f of x plus g of x, which is, we plug in what we're told, f of x is x squared plus 5x, and g of x is 3x plus 2. Simplify this, combine our like terms, and so f plus g of x is x squared plus 8x plus 2. Write down your questions as you have them. F of x minus g of x is x squared plus 5x minus parentheses. My classes, you're probably sick of hearing me say that, but it's vital. Parentheses around the entire thing. Then we have to subtract the whole thing, each term. X squared plus 5x minus 3x minus 2. If you don't use parentheses, you'll end up adding 2, and that would be wrong. Again, we simplify x squared plus 2x plus 2, and we're done with that. F times g of x. This is going to be a little trickier. I need a little more room, so I'm going to erase what I have written over here. All right. So this is f of x times g of x, which is x squared plus 5x times 3x plus 2. I'm going to have to distribute these. I need to multiply them. So x squared times 3x is 3x cubed. X squared times 2 is plus 2x squared. 5x times 3x is 15x squared. And then 5x times 2 is plus 10x. Combine my like terms, and I have 3x cubed plus 17x squared plus 10x. And I'm done. If you'd like, go on ahead and try D, E, and F on your own. We can talk about those in class when we talk about this section. Of course, you can also come in before then, before, after school, during lunch, if you have questions that you need answered right away. So that was it for adding, subtracting, multiplying, and dividing functions. Fairly straightforward. We just use our definitions. Now we're going to talk about something that's a little different, and that is composing functions. You may have seen this before, maybe in Algebra 2, but if you haven't, or as a refresher, here's our definition. Given two functions f and g, we have the composite function f of g. F of g, I know it looks like fog, but that's really just a little o in between. F of g is defined by f of g of x. That's basically it. So, it looks weird, I know, but remember when I gave you a function like f of x equals x squared plus 1. If I asked you to evaluate f of 2, you know that whatever is inside the parentheses here, you're plugging in anywhere you see an x, which is 5. It's the exact same thing here. So I'm asking you instead f of g of x. So everywhere I see an x, I'm plugging in g of x squared plus 1. Now, that means I need to know what g of x is, and I need to evaluate g of x. Sounds crazy. It's like Inception. It's one of my favorite movies. A function within a function. And we'll see some examples a little later on where we have a function within a function within a function. 3 levels in, not 4 or 5 like the movie, but that's okay. It's still possible. So to put that more into concrete terms, let's run through some examples. These are great examples. They start off pretty simple, and then they work their way up. So example 3, let f of x equal x squared and g of x equal x minus 3. Find the functions f of g and g of f. Now, composing functions means the order matters. These will be two very different things, as we will very shortly see. Let's start with f of g. According to our definition, this is the same as f of g of x. G of x is x minus 3. So I have f of x minus 3 instead of just f of x. And so now I take this x minus 3 and I plug it into my original f of x. So everywhere I see an x, I'm plugging in x minus 3. X minus 3 squared. I'm going to have to FOIL this or distribute, whichever term you prefer. So this is going to be x minus 3 times x minus 3, which is x squared minus 6x plus 9. And I'm done. That is f of g of x. G of f, on the other hand, according to our definition, is g of f of x. So now I have g of whatever my f of x was, x squared. And so now, everywhere I see an x in g of x, I'm instead plugging in x squared. X squared minus 3. And that's it. I'm done. I can't simplify that anymore. So those are two very different functions, x squared minus 6x plus 9 and x squared minus 3. Very different. Order matters. For part B, we have f of g of 5. We just found f of g, and we said that was x squared minus 6x plus 9. So, f of g of 5 really don't understand why this keeps erasing. Come on, Apple. F of g of 5 is, everywhere I see an x in what I found to be f of g, I'm plugging in a 5. So 5 squared minus 6 times 5 plus 9. 25 minus 30 plus 9, which is, if my math is correct, 4. Negative 5 plus 9 is 4. G of f of 7, I found g of f to be x squared minus 3. So I plug in 7 anywhere there's an x there. I'm evaluating that combined function for 7, and I get 7 squared, not plus, minus 3, which is 49 minus 3, which is 46. At any point you need to pause this, do so. Pause. Make sure you understand. Make sure you're writing down questions. If you need to go back and watch what I've just done again, do so. This is to help you. So we're nearing the end here. Look, we're at the last page. I know this video's been a little long, but bear with me. It's a lot to cover. Example 4, we have f of g and g of f. And I want you to try these two on your own. So notice we have a new f of x and a new g of x. So try these two on your own. I gave you all the printed guided notes this week, so you should have plenty of room there to try this out, and we'll go over the answers together in class. I will run through C and D with you, though. So f of f. Yes, we can combine a function, compose a function with itself. Isn't math cool? F of f is defined as f of x, which is f of, my f of x is x squared plus 3x. So this will not be fun, but we can do it. We have, anywhere I see an x in f of x, I'm instead plugging in x squared plus 3x. So x squared plus 3x squared plus 3 times x squared plus 3x. Crazy inception. I love it. Let's now FOIL this here. And we're going to get, if I did this correctly, x to the 4th plus 3x cubed plus 3x cubed plus 9x squared. And now let's include this when we distribute the 3. We have plus 3x squared plus 9x. And if I combine my like terms there, what I end up with is x to the 4th plus 6x cubed plus 12x squared plus 9x. Hopefully I didn't lose you again. Please, if you have a question about any of this, make sure to write it down. Letter D is much easier. We have g of g, which is defined as g of x. And that is just g of x is the square root of x. So we have the square root of x. Yes, we can have a square root of a square root. It's crazy, but it's totally possible, and I love it. It makes sense if I have the square root of x. So suppose x is 4. I have the square root of 4, which is 2. But that itself is inside a square root. So now I just have the square root of 2. All we'd have to do is simplify. So that is C and D. We're now on our last example. And we're nearing the end. Don't worry, I know. These aren't too bad. G of x. Well, g of x is x to the 10. So we have g of x to the 10. So everywhere I see an x in my g of x, I'm plugging in x to the 10th. So this is x to the 10th to the 10th. I am raising a power to a power. That means I multiply them. If we remember our exponent rules. So I have x to the 10 times 10, which is x to the 100th power. One more. Here's that crazy 3-level composition that I warned you about earlier. We have f of h of g of x. So much fun. And I hope I don't sound sarcastic. I truly do think this is fun. We have f of h of g of x, we said, was x to the 10th. So we have f of, now we need to evaluate h for x to the 10th. So h of x is x plus 3. We evaluate that for x to the 10th. When I evaluate, I'm thinking substitution. So everywhere I see an x in my h of x, I'm instead plugging in x to the 10th. And I have x to the 10th plus 3. So now we're back at just our usual composition of functions. I have f of x to the 10th plus 3. So in my f of x, and this should be f of x, sorry about that typo there. For my f of x, everywhere I see an x, I'm plugging in x to the 10th plus 3. So I have x to the 10th plus 3 over x to the 10th plus 3 plus 1, which is x to the 10th plus 3 over x to the 10th plus 4. And that is f of h of g of x. Composing functions, we're going to have some activities to do in class. Hopefully this makes some sense to you. If not, rewatch parts of this video that were confusing for you, write down your questions, work through examples. Don't be afraid to reach out. I hope this video was helpful for you. I hope you are having a fantastic weekend, and I'll see you in class. Thank you.